permit me to stand on existing protocols, but I have to pay, respect to the President, Nigerian Society of Engineers, ably represented, the National Chairman, NIMechE, of course, the Chairman of the Board of Fellows of NIMechE, distinguished members of the executives of the board, and all our beloved conferees of the NIMechE Fellowship. I must say that it's a very intimidating gathering when you are called to speak to a group of conferees who have achieved so much in their career and are being recognized for the leadership role they have played. What do we want to talk to them about rather than seek for their own advice? But of course, if I'm able to speak about the problems in Nigeria, then maybe they would then be able to say, you know what, contact me, I will tell you all the solutions. So permit me as I speak to you, not as someone that has all the answers, but someone that has all the questions, hoping that later on we can converse and get more solutions to our problems. My name is Dr. Olusola Ayoola. I'm the founder of Robotics and AI Nigeria, and I will be speaking about creating a smarter and safer future for all of us in the world with AI-driven mechanical engineering solutions. Next slide, please. Before we talk about the future, let's talk about the past. About 40 years ago in India was a significant disaster that created so much news back in the days, 1974. This is about Bhopal gas tragedy that happened back then. Next slide. It's a pesticide manufacturing plant. What happened was that there is a particular kind of chemical, MIC, that is stored in a tank underground. But that particular chemical must not get in contact with water. Otherwise, it will result in an exothermic reaction that will create heat, build up of pressure, and of course, some very hazardous gas. It's okay when you want to destroy pests on the farm, insects and cockroaches and all that. But talk about releasing that kind of amount of gas to a population of human beings sleeping in their bedrooms in the middle of the night. The entire community was enveloped in that gas that eventually resulted in a total death of about over 15,000 people. And 500,000 people were either injured, became permanently blind, or deformed. Now that was a devastating occurrence caused by some factors. Somebody said it was because an operator was not knowledgeable enough about the danger of allowing water to get into that tank. Somebody said it was because the factory did not maintain the valve that could stop water from going in. Somebody said because the people in the control room ignored the sensor that showed pressure was building up in the tank. But regardless of all the excuses and the causes, it just says one thing, that as human beings, we don't have all the answers. Sometimes we need systems that can learn over time and tell us when we are not doing the right thing. Next slide. But if you think that was 40 years ago, then how about 2 years ago? A company called Ocean Gates developed a submersible which was ingenious because it could take them underwater, as deep as 4 kilometers underwater, to observe the wreckage of Titanic. Even though they had succeeded to go on that trip 4 times, on the 5th time, the vessel imploded. And I'm sure you heard about the story. It was so sad because there were warnings that were given. The material that was used, unfortunately, because of the type of material, could not be analyzed using the finite element analysis method. It was carbon fiber material. And so, we learn every day. But then, the question is, next slide please. The question is, what is the reality? When I was developing this slide, I started asking myself, I'm looking for specific mechanical engineering solutions. There were none. Reason being that mechanical engineering is everywhere around us. Call it civil engineering, call it industrial engineering, call it agricultural engineering. Everything is mechanical. And that is because the world depends on forces, momentum, and all the laws of mechanics that control movements and progress. And so we can't escape from mechanical engineering solutions. We have to all come together to develop safer and, of course, smarter solutions. Surviving based on advanced principles of efficiency and precision must be our hallmark. And today, as we confer fellowship to experienced and achievers in the field of mechanical engineering, the question we would have to ask ourselves is, what are the things to consider when analyzing a problem, when designing a solution, when building it, when operating and maintaining? Are there smarter ways you have developed over time that the world can now begin to embrace? Maybe you have, but AI offers additional layers for safety and smartness. So next slide. The role of mechanical engineering, like I said earlier, is ubiquitous. From the robot arms that are now being used in assembly plants to vehicles that are becoming smarter every day. Of course, on the farm you have tractors. Talk about processing plants, and of course the issues of flights and all sorts of mobility. Day to day, people are fabricating new solutions. How much of mechanical engineering is involved in that? I recall the days of COVID-19 when Nigerians said they have built their own ventilators. And some medical doctors refused to use these ventilators because they were not carried along in the process of building this. Mechanical engineers too have a right to say, no, we won't approve or support the use because we were also not carried along. These are our laid down standards for design, building and all that you have not followed. Even in the area of defense and home support, there are so many solutions today going into our homes that may or may not be safe. How much of endorsements have they secured from NIMechE? These are questions we have to ask ourselves. Next slide. But then, before we talk about whether something is smarter or safer, what do these terminologies mean to us? When we say smarter, it means achieving the goals with greater efficiency and accuracy, even in the face of complex problems. Optimizing the results through enhanced decision making. And finally, data-driven with insights for improved performance. Now, when we use the word data-driven, because we are now in a time where the world is using AI. So what does data-driven mean? You can't use AI without data. How much data do we collect? And that's going to be one of my recommendations at the end of this presentation, that we must collect data from our various experiences that can be used to build a solution using AI. Safer. What does it mean for something to be safer? It has to have a rate of detection of, let me say hazards, faster than we humans can detect it. I look forward to a time when the valves would know when to shut or when to open, rather than us blaming the person who was supposed to supervise it. We need to be able to reduce human risks in hazardous tasks. And that is why when people say, oh, don't bring in AI or robotics, it will take away our jobs. I say to them, I don't mind robotics and AI taking away our jobs if it will help us restore our lives, because lives cannot be replaced, jobs can be replaced. Reduction in potential accidents due to human error. There have been so many industrial incidents that eventually there will be reports on this. How much of that data from the incidents have we used to learn for the future? Next slide. So, today we are going to be focusing on how AI can impact in the field of mechanical engineering under these 5 pillars. Number 1, our ability to analyze the problems before we build a mechanical solution. Number 2, our ability to design the solution we hope to build in a smarter way with safety in the design. Number 3, the way we build solutions. Because when we are building, sometimes the person that designed it and the person that is building it may not communicate well enough. How can we use AI to ensure that the entire requirements at the level of design will be followed through to the end at the level of building? Then, of course, operation. When you build and you hand over to the operators, sometimes they may be confused as to what to do. I was in a factory some time ago, and one of the heads, the supervisor, said to me, "Can you build an AI system? Because every time we bring in new workers, we have to explain to them about various machineries. And when they encounter a problem, they have to wait until someone who is more experienced is available to explain to them what they should have done right or what they can do to fix it." So he said, "Why can't we have an app using AI, computer vision, that can just, when you make the camera face the machine, it already detects what the name of this machine is, what the challenges of this machine could be, how to fix it when there is that fault, so that even a novice would not give the excuse when he makes a mistake." Then, of course, number 5, maintenance. The world has gone past the idea of saying, take note of what you're going to maintain today or tomorrow. Now, you can even replay the events that a particular system has passed through. I'll give an example. Aeroplanes, over time, they're exposed to heat, sometimes exposed to low fuel and high fuel and whatever, maybe an increase in their consumption rate and so on of fuel. Eventually, if a plane crashes, it is not just the black box we will try to listen to. There is what we now call digital twin. That means that all those times the plane was flying to America, to China, all those times the fuel was going down and was being refilled, all those times the heat in the engine was rising and falling, it was all logged. All that data was logged. We would then discover if there is a pattern consistent with planes that eventually have one issue or the other, just to make sure that we are learning. So digital twin is when every data about whether it's an aeroplane or car or even your fridge at home is stored, so that we can replay it the way we replay CCTV footages. So these are the things we'll be looking at. But before then, what is AI? And I'll just be very brief about this. AI, in layman terms, is the ability of a computer-based system to mimic the human brain in terms of our cognitive ability, our understanding of events, and of course, our ability to make decisions. But if we go in depth, it's the ability of a computer-based system to collect data from its environment. So if you are not building a machine that can collect data, there's no way you can implement AI on that machine. So thank God for instrumentations, we can collect data. But not just that. When it collects the data, it needs to process that data using what we call heuristic algorithms. Heuristic algorithms means a computer program that is not hard-coded. It can update its understanding of the situation as it learns. And when we say heuristic, we're basically talking about a polynomial equation, expression. For example, when they tell you x squared plus 3x plus 4, it's fixed already. But if I tell you ax squared plus bx plus c, whenever a, b, and c change, the equation will change. So all the computer is doing is constantly trying to re-understand whether A has changed, B has changed, C has changed, or not. And it's what we learned in statistics, regression analysis. That is basically what AI is about. When it understands its environment, it's then able to make informed decisions. So this is what AI is about. Next slide. And there are classes of AI. We have the predictive AI and the generative AI. I had to spell this out because our regular interaction with AI today is about ChatGPT, Gemini, and co. And these are all under generative AI. Generative AI is an AI that is able to generate output the way human beings would. For example, okay, write a letter for me, it will write it. Give me a picture of this, it would give you a picture of that. But that's just generative, showing that AI too can be creative. But looking at the other aspect, predictive AI, is an AI that uses what I just mentioned, explained earlier, predictive regression analysis, to understand what the future holds. For instance, in mathematics, we give sequence 2, 3, 5. and you are told what is the next number. That is what AI, predictive AI, can do. It can predict the next event. And the data would not be numbers this time around. It could be a sequence of activities. It could be data from your chats. It could be data from your bank account balance or events that have happened in your life. So, and that is something that in AI we use a lot for recommender systems, and I will explain what that is very quickly. Recommender system is something that is used to understand human behavior. And of course, Netflix, YouTube, all these social media platforms use recommender systems a lot. They understand what your sequence of behavior, what do you do on their platforms, and then they share it as cookies, so that when next you go to another platform and you behave one way, they already know what you're like and what they can use to retain your interest on their platforms. So yes, there is so much under predictive AI, but we don't have time. Generally, there are 3 types of AI based on the work that they do. Number 1, narrow AI, then of course the general AI and the super AI. At the moment, with all you have seen with AI, how it has grown so fast, we are still at the level of narrow AI, an AI that can do based on what we have trained it to do. Whether it is ChatGPT, so interesting, so intelligent, it is still narrow AI. It was trained. The data came from all of us. But think about the next level of AI, general AI. That is an AI that is able to learn on its own, not because we gave it data about ourselves, but because it can think beyond how we have been thinking and writing and giving it data. Now that is still to come. But eventually, super AI will be the kind of AI that is almost like a spiritual being, in the sense that it knows beyond what we even know. But that's because we can predict that with the level of growth today, so much can be achieved as humans get more and more creative. Next slide. So when it comes to, I'm rounding up now with this, breaking it down to our basics in mechanical engineering. How do we design? With AI, there is now the possibility of virtual prototyping. When you want to showcase an idea, let's give, for example, construction of a bridge, and you need to test if your understanding of the material strength and so on will be sufficient. You would not have to build it at first. With virtual environments now, we can build and test. Of course, eventually there will be need to build the final version, but it helps us to prototype very quickly and have an understanding of what the eventual product will look like. Generative designs. There are applications today, and when I say applications today, it's still the normal ones we know, but they have added extra features. For example, Fusion 360, AutoCAD, SolidWorks. They have added features now that allow for generative designs so that you can quickly scale from one level to another. Predictive analysis, of course, of what will happen based on AI. So how much are we integrating AI in our design? That is one. Next slide. In the case of building phase, it's time for us to apply some level of automation. And I'm saying this because, interestingly, a company reached out to me from Abuja and said they have so many activities to manage, to supervise, and they can't be so confident about what one field worker is doing somewhere or not. So they requested for a kind of software that will be on the tablet, so that if you have a particular job to do, as you accomplish each job, you tick on the app. And if you don't tick on the app, they know you have skipped it. Not only that, the app is reading your location. So you cannot claim you have inspected when your location does not show you have been there. And this is called workflow automation. You get an alert about what you need to do when you need to do it. So even a newcomer would have guidance at every point of the work. This is not just for the person in Abuja. A company in Canada also were looking for a solution. They are into fabrication, and when a task comes in, there are many requirements customized requirements for each task. They are into foundering. So there could be bench press, there could be bench sheet folding, and so on, required for a particular job. But what they simply needed was some sort of sequencing, so that when you take on a particular job, everything you need to do will be alerted to you as you go by. So that way, you're not leaving it to the smartness or not of the person involved in the task. Rather, you're allowing a system that can monitor the person. And what does that also do for us? It also helps us to monitor the speed of the worker, the articulation of the worker, and how well the worker understands and doesn't make mistakes. Because if we cannot measure, we can't improve. So also, if you cannot measure the performance of any of your staff in the engineering field, you can't guide them or help them to grow. Next slide. Now, this is the one I had talked about. When it comes to operating specific equipment in the office or in the factory, it is important to apply computer vision and large language models. Now, what is large language models? Large language models, an example is ChatGPT that we can converse with. Now, imagine I am working in a factory and the lathe machine has stopped working, but it's still maybe giving me a signal here, it's just not responding. It will be a downtime if I have to go and look for someone knowledgeable to explain it. Then they call a contractor to get the service company to look at it. Whereas, if there is already an LLM solution for that particular machine, every possible question one will ask will have its answer. Now, where do we start from? Should we therefore request for the owners of OpenAI to build an LLM model that can help us understand this machine? No. There is already what they call fine-tuning. That means that the models already exist. It's just the data that is not yet there. For example, you have a lathe machine. Do you have every possible story about what can go wrong and every possible response to it? If your company already has, you can then fine-tune an OpenAI model or any other, maybe Gemini model. And by doing so, you have a solution that I'm here referring to. Every other player in the field can utilize your own solution. Same thing for every other kind of material equipment you will be involved in. Now, that's for natural language processing. Whereas computer vision, on the other hand, says to us, you don't even need to know the name of this particular machine to begin to ask questions about it. Just get your camera to focus on the machine, and immediately, by looking at what light is coming on, what sound is not making up, or what sound is coming up, it can infer. And you know, it's interesting because in Nigeria today, we have some very smart, computerized automotive engineering companies that try to help diagnose a car's issue. From the sound alone, they can detect what's going wrong. From the exhaust, they can detect what's going wrong. So that is, again, an aspect of AI that we can continue to build on. Next slide. When it comes to maintenance, this is one that is very critical. And that's because most of the challenges come from poor maintenance culture. And I'm not going to say that Nigeria has such, but of course, we can pretend that it doesn't. But people will always tell us that in Nigeria, we are not totally considerate about the requirement for maintenance. People get contracts, and on the contract term, there is nothing that says budget for yearly maintenance until something packs up. And then we have a lot of moribund equipment that need to be rehabilitated. So, can we please utilize artificial intelligence of things and, of course, digital twinning that I had tried to explain earlier to guide our maintenance culture here in Nigeria? And how is that possible? Every equipment, every machinery, whether it's a vehicle, whether it's a forklift, must have sensors that we can use to collect data. And this is very basic. Sensors already exist. We use them in our factories, but do we record the data? Apart from displaying it on the SCADA systems, do we have a log of everything? Can we collaborate with those who are into data science to try to understand if the behavior of this machine today is still normal or is becoming abnormal, so that we know when to service it or when not to? Now, this is the level of digital twinning and artificial intelligence of things. And it will help a lot to minimize costs, to enhance the diagnostic functionality of our systems, and of course, to optimize the life cycle. Next slide. So, there are some existing solutions already. I mean, when it comes to smart engineering, smart mechanical engineering, Tesla is one of them. Toyota is another example, and some smart robotic arms are also examples. Let me start with the robotic arm. When we say robotic arms are being used in the factory, that is because it's a robot, but not exactly. we now have something we call cobots, which is collaborative robotics. Robots that can function even within a space of human beings, so that we don't have to be avoiding it because it may not notice us. So what we now have are robotic arms that are aware of our presence. So if the robotic arm is supposed to swing to drop something here, and I get in the way, it will stop and tell me to excuse. Now, in that case, we are safe even within such a smart environment. Now, that is great. Also, with Tesla has built cars that are self-driving, but not just for the fun of it, but so that when the driver, who is the operator, falls asleep or tries to do what is wrong, the car itself will be smart enough. And how did they do that? They put sensors. What kind of sensors? Camera systems that are sharp enough is one way of collecting data about the environment. Computer vision, on the other end, is how we process the footage from the camera. Already, people have a lot of projects, even within the Nigerian university system, about road awareness using AI. So all that is needed to be done is put those cameras around the vehicle, connect the footage to a computer that has an algorithm for road awareness. So whenever there is probably a human being or a traffic light that is telling them to stop, the car will be alerted. But then there's a misjoint here. The person that knows about computer vision is not a mechanical engineer. The person who is a mechanical engineer is probably not aware of how these things can be integrated. So we need to collaborate and close the gap. So here are my recommendations. Number one, we have to have constructive regulations. Regulations that will not inhibit growth. Because when we talk of regulation in this AI space, people are like, very good. We need to stop AI before it takes our job. No. We must allow AI, but constructively regulate so that it is enhancing our work. Time is gone. Thank you, sir. We also have to have some sort of employment and skill development solution. I'm saying this because these are fellows, and I'm very sure many undergraduates and even fresh graduates will be happy that it's being said here. How can we encourage them to learn AI and bring that knowledge? Is by creating avenue for them to experience the problems in the field, maybe by coming for internship, and then going back to learn what is required to solve the problem. I have an example of someone who went to a foundry company, understood the problem there, and the problem they had there was there were so many parts that were important to them, but staff workers in the factory would use some item and not return it back to where they took it from. So that way, there was always that sorting that needed to be done after the day's work. So what did he implement? A smart system where every item is trackable with RFID, so that wherever it is on a computer system, you can see, oh, they left this particular one there or not. So also with files. So there are a lot of solutions. Next slide. AI knowledge and talent development. So I think this is self-explanatory. We need to rejig our curriculum. And I will just mention one thing before I conclude. I know of someone who studied mechanical engineering and wants to now cross into control systems so that he can combine that knowledge to make mechanical engineering solutions that are smart. Unfortunately, he approached a university that I will not mention its name, and the university said, sorry, for you to study control, you have to have a background in electrical, not mechanical. Whereas this same young man, if you should go abroad, there is no limit. If you can show reasons, if you can show some skills you have developed on your own, they will admit you. I know of somebody who finished from chemistry, went abroad, and is studying computer science now on PhD level because he showed he had been through a one-year AI program. Now, we need to stop being too rigid in our academic system so as to allow skillful people to support one another in various project solutions. On that note, I'll conclude with the next slide. With an increasingly lazy generation, faced with increasingly complex challenges, the world needs smarter, yet safer mechanical systems. In the above are opportunities for professionals who tap into them early and seek collaboration. It is still not too late to join the party. Upskill now. Thank you for listening.
A better round of applause for very long time been hearing of AI. I never knew there are types, predictive and generative. I think it's a good thing that we take out of this lecture. And the good side of the lecture also tells us that AI cannot just run on its own except you have data. Yeah. Please, let us make a round of applause for our guest lecturer. Thank you very much. As customary to Nigerian Institution of Mechanical Engineers, Doctor, when you speak to us in events like this, we have to reward you and appreciate you. No, we fellowship. On this note, on this note, my national chairman, president of Nigerian Site of Engineers, represented. Please, the national chairman, may you come forward to present to the guest lecturer an award for doing this service to us. A round of applause for him.